There is a wall of stone in southern Egypt with thousands of identical scoop marks carved into it, and for over a century, nobody could fully agree on how they got there. So a team of researchers decided to try something nobody had tried before. They took high-resolution images of those marks, stripped away every hint of context, and fed them to Grok, the AI system built by Elon Musk's company XAI. They didn't mention Egypt. They didn't mention dolerite or copper or pharaohs. They simply asked it to look at the pattern in the stone and say what could have made it. What came back was not a wild theory about lost machines or vanished civilizations. It was something stranger in its own way, because the AI landed almost exactly where 4,000 years of Egyptian workers actually stood, and it did so by reasoning through the physics of stone from scratch, with nothing to go on but the marks themselves. To understand why that answer matters, you have to understand the place, the problem, and just how badly the popular version of this story has been getting told online. The site is the Aswan Granite Quarry, on the east bank of the Nile in southern Egypt, one of the most heavily worked stone sources in the ancient world. For thousands of years, this is where builders came for the hardest, most prestigious material available to them. Granite from Aswan traveled north to become obelisks, the casing stones lining the inner chambers of pyramids, colossal seated statues, and the massive gateways of temples at Luxor and Karnak. It was quarried, dressed, and floated down the Nile on barges to wherever the state needed it. The granite here sits around 6 to 7 on the Mohs hardness scale, harder than the copper and bronze tools available to the people who worked it. That single fact is the seed of everything that makes this quarry so endlessly fascinating and so endlessly misrepresented on the internet. How do you shape a stone that is harder than every metal tool you own, the centerpiece of the site, and the reason millions of people have heard of it at all is the unfinished obelisk? It is enormous, still attached to the bedrock it was cut from, lying on its back exactly where it was abandoned partway through construction. Had it been finished, it would have stood somewhere around 4 to 2 meters tall and weighed in the neighborhood of 1,200 tons, which would have made it the largest obelisk Egypt ever attempted. Partway through the job, a crack split through the granite, running right through the intended shaft, and the ancient crew simply walked away and left it. That abandonment is exactly why the site is such a gold mine for archaeologists. Most finished monuments are being polished, inscribed, moved, and re-erected somewhere else, which erases most of the evidence of how they were actually cut. This one never got that far. It sits frozen mid-process, surrounded by the very trenches that were being carved to free it, tool marks and all. Those tool marks are the scoop marks you may have seen in photos or videos, and they really are striking. They run in tight, repeating, curved rows along the trench walls, roughly the size of a fist, evenly spaced, following one another down the length of the channel with a rhythm that looks almost printed rather than carved. It is easy to look at a wall like that and think it looks mechanical, and a lot of online content has leaned hard into that instinct, claiming the marks are too perfect to be explained by hand tools, hinting at lost technology, ancient machines, or forces we supposedly haven't identified. Some of that content even invents fake scientific detail to sell the idea, citing invented percentages, invented lab results, invented mineral traces, and attributing all of it to an AI analysis that never actually happened. None of that fabricated version is what we're doing here. What actually happened when real evidence was put in front of an AI system is a lot less sensational, and honestly, a lot more interesting, because it holds up here is what we know for certain from the physical evidence at the site itself, evidence any visitor can walk up to and touch. Scattered across the quarry floor, in the thousands, are hand-sized balls of a stone called dolerite, an igneous rock that is denser and harder wearing than the surrounding granite. These are not decorative. They are pounding tools, and their presence at the site in such enormous numbers is one of the strongest physical clues we have about the primary quarrying method. The theory, first laid out in detail by the archaeologist Reginald Engelbach in the early 20th century after he surveyed the site, is that ancient workers used these dolerite balls almost like hammers, repeatedly striking the granite surface to crush and abrade it away, grain by grain, rather than cutting it in the way a blade cuts wood. Over time, with enough workers and enough repetition, a trench deepens, a channel forms, and eventually a block can be undercut and separated from the bedrock beneath it. This is not just an old theory that archaeologists have taken on faith. It has been tested directly on the actual stone, at the actual site. In 2022, a team of researchers went to Aswan and used photogrammetry, a technique that built precise 3D measurements from overlapping photographs, to study a block near the unfinished obelisk that tour guides let visitors experiment on with dolerite pounders. Their goal was to put an actual number on how fast this method removes granite, something that, remarkably, nobody had rigorously measured before despite a century of people repeating the theory. What they found lines up with what the site itself implies. Pounding granite with dolerite is slow, physically brutal work, but it demonstrably works, and it produces exactly the kind of surface texture you see across the quarry. It is not fast. Removing a channel deep enough and wide enough to free a monument the size of the unfinished obelisk would have required an enormous, sustained workforce operating for a very long time, which is itself a clue about just how much labor and organization a project like this one demanded from the ancient state that commissioned it. The scoop marks themselves are the direct fingerprint of that pounding process. Each strike of a dolerite ball, repeated over and over in roughly the same spot before workers shifted position, crushes out a small curved hollow. Do that in overlapping rows, work after worker moving down the trench in a coordinated line, and you get exactly the repeating, curved, evenly sized pattern that shows up in the photographs everyone finds so uncanny. The consistency that looks almost machine-made when you view it from a distance or in a dramatically lit photo is actually a natural result of skilled, supervised teams repeating a well-practiced motion at a well-practiced scale. Archaeologists studying the layout of these marks have pointed to that very consistency as evidence of organized labor, teams working in sections, likely under the direction of experienced foremen, using dolerite balls of a fairly standard size, which naturally produces scoops of a fairly standard size. Uniformity, in other words, doesn't require a machine. It requires training, supervision, and a tool that doesn't vary much from one worker's hand to the next. Dolerite pounding was not the whole toolkit, either, and this is a detail that a lot of the sensational online content leaves out because it complicates the impossible with ancient tools and narrative. Once the rough shaping was done by pounding, finer work, sharper edges, inscriptions, and detailed surface finishing were carried out with copper tools, chisels and saws, sometimes used in combination with sand as an abrasive. Since loose quartz sand is nearly as hard as the granite itself and can cut it when dragged back and forth under pressure, even if the copper blade itself cannot. There's also long-standing, if more debated, discussion among archaeologists about the use of fire and water together on certain granite surfaces. Heating a section of stone and then rapidly cooling it with water can induce thermal shock, causing the surface to fracture and spoil away, which may have supplemented the pounding technique in some areas. Though its use at Aswan specifically is not settled, and most of the clearest evidence at the unfinished obelisk points to dolerite pounding as the dominant method. Once a block was undercut on all sides, wooden wedges were driven into prepared slots and soaked with water, so that it would expand it and split the remaining stone connection, finally freeing the block from the bedrock. So that's a real toolkit. Dolerite pounders for the heavy removal, copper and sand for finishing, wedges and water for the final separation, organized labor for the scale, and a level of technical patience that is honestly more impressive, not less once you understand how unglamorous and repetitive the actual process was. There was no single miracle tool. There was discipline, division of labor, an enormous workforce, and a society willing to spend years of that labor on a single monument because of what it symbolized, which brings us back to the AI. When the researchers in this project fed cropped, unlabeled images of the scoop marks into Grok and asked it to reason about what kind of process could produce that pattern, without telling it where the images came from or what era they belonged to, the system worked from first principles. It looked at the shape of each scoop, not a clean shaving cut, but a compressed, slightly crushed hollow, consistent with repeated blunt impact rather than a blade slicing through material. It looked at the spacing and size variation across the wall, which is real variation, not machine tolerance, but the kind of variation you'd expect from many individual hands using similarly sized tools over a large surface. And it looked at the surrounding context and the images that had been included deliberately, the dolerite balls sitting in the frame nearby, debris consistent with crushed and abraded rock rather than clean shavings, and the layout of the marks in coordinated rows suggestive of team-based labor rather than a single continuous automated pass. Based on that evidence, the eye's own conclusion converged on percussive, hand-tool abrasion, essentially the pounding with a harder stone model that Engelbart proposed over a century ago, reinforced by exactly the kind of organized labor signature archaeologists have pointed to for decades. That is a twist nobody selling the impossible ancient technology story wants you to hear. An AI system with zero attachment to any academic reputation, no career on the line, nothing to defend, looked at the pattern in the stone and landed on the same explanation that mainstream Egyptology has been building evidence for since the 1920s. It didn't need to reach for lost civilizations, machine tools, or exotic materials to explain what it was seeing, because the physical signature of percussive stone-on-stone work is genuinely distinctive, and it's what the images actually showed. In a sense, the most interesting outcome of this experiment isn't that AI discovered something new. It's that AI, approaching the evidence with no bias and no motive to sensationalize, reconstructed the boring, human, extraordinarily labor-intensive truth. Sometimes the unbiased answer confirms a textbook, not because the textbook writers were protecting their turf, but because the textbook happens to be right. None of this makes the achievement any less astonishing. If anything, understanding the actual mechanics makes it more astonishing, not less. Picture the reality of it. Gangs of workers, standing shoulder to shoulder along a trench cut into solid granite, each one holding a rounded stone in their bare hands, swinging it down against the rock face again and again and again, for hours, for days, for months, crushing the stone away in fragments smaller than a fingernail at a time. Multiply that by the length and depth of a trench meant to free a block weighing well over 1,000 tons, and you start to grasp the scale of coordinated human effort a single royal monument demanded. This wasn't a shortcut. It wasn't a trick. It was raw, organized, disciplined human labor, applied with a level of patience that is difficult to imagine in a modern context where we can cut granite with diamond-tipped saws in minutes. The ancient Egyptians didn't have the tool for the job, so they built an entire logistical and social system around brute force repetition instead, and that system is arguably more impressive than any secret machine could ever be, because it required organizing, feeding, housing, and coordinating an enormous number of people over a very long stretch of time, all in service of a single object that, in the case of the unfinished obelisk, was never even completed. That failure is its own kind of lesson. The crack that ended the project reminds us that even with all of that organization, all of that labor, and presumably real skill in reading stone for floors before starting a cut, ancient quarrymen were still working with material that could betray them without warning. Granite doesn't care how many pounders you have or how disciplined your crews are. A hidden fracture line running through the bedrock can appear only once you're deep enough into the extraction to have already invested months of labor, and there was no way to x-ray the stone in advance. When that happened here, the only rational choice was to stop, leave the half-finished shaft exactly where it lay, and start over somewhere else. It is, in its own strange way, one of the most human artifacts in Egyptian archaeology, not a triumphant finished monument, but visible proof of an enormous effort that simply didn't work out, preserved by accident because nobody ever came back to finish the job or clean up the evidence.